Okay, below is a scale diagram of a submarine. The body of the submarine is roughly the shape of a cylinder with a cone at one end and a hemisphere at the other end. Measure the lengths labeled R, D, and H. Oh, measure the lengths labeled R, D, and H on the diagram above. Write the lengths of each correct to the nearest centimeter. Man, the problem is, um, I'm on the digital one. So, is there any way I can? Yeah. Let me see. Let me hold up an A4 page. At least zoom in enough so that it's the same. Okay. That's a little too small. How can I adjust the zoom? That is pretty close to actual, but a little bit bigger. So I might want to knock a millimeter or two off. Um, Best I can with my ruler. Oh dear. The or on my root. No, I think that's pretty good actually. The or measure the lengths in the diagram to near centimeter. Okay, that should be all right then. One. Oh, now that's 10, I'd say. And then that's 3, no doubt. Okay, the actual total length of submarines on the diagram, the scale diagram above, is 90. Use the measurements from that part to work out the actual length for each. Okay, so the real submarine actual total is 90. So 10 plus 3 plus 1 is 14. Now it makes me wonder if I should have gone with 11 here because but did say one decimal place, so maybe my screen isn't too inaccurate. So 80 divided by 1 plus 10 plus 3. So this would have to be scaled up by 40 over 7, like about 5.714. To one decimal place, so that'd be 5.7. Oh, well, it's 90 meters, I suppose. So, 5.7. This is 10 times bigger as the previous 57.1. And then 17.1 meters. 17.1 plus 57.1 plus 5.7 is 79.9. So, 70. Oh, I mistyped it. Rats, I typed it in as 80 instead of 90. Why was I thinking 80? 90 divided by 1 plus 10 plus 3. It's scaling up by 6, or rather 643 times bigger, roughly. So that would be 6.4, and then this one would be 64.3, and then this last one would be 19.3. 19.3 plus 64.3 plus 6.4 is 90. Okay. The diagram below shows the body of a different sub with similar design. The dimensions are all given in terms of x. The volume is that. By solving, find the total length. Okay, so the volume. So 2 over 3 pi x squared plus pi x squared 7x plus 1/3 pi x squared 4x. So that is 2/3 pi x squared plus 7 pi x 8 plus 4/3 pi x cubed should equal 6738. Is that right? Why do I have x7? No, that couldn't be right. Why did that happen? I'm tired. That's why that happened. Pi x squared, and then it's pi. Yeah, why did I write 7 here? That's very silly of me. Oh dear. Dear, oh dear. Stephen, you are tired today. 2/3 plus pi x squared 7x. Okay. Pi r cubed. Oh, come on, Stephen. 4/3 pi r cubed divided by 2. Pi r squared h. 1/3. Okay, so that's 2/3 pi x cubed plus 7 pi x cubed plus 4/3 pi x cubed equals 6738. Okay. 2 divided by 3 plus 7 plus 4/3. So that is 9 pi x cubed equals 6738. So then cube root that to 1 decimal place, 6.2 meters. Now let me double check that. 2 divided by 3 times pi times 6.2 cubed plus pi times 7 times 6.2 cubed plus 1/3 times pi times 4 times 6.2 cubed, 6738. Yeah, that looks okay. Right, a submarine is within route 58 kilometers of point A and within route 178 of point B. This is represented on the coordinate diagram below. The points 0, 0 and 20, 0 are shown. Parts of the circle K and S are shown. K is that center, that radius. The submarine is in the shaded region or. Write down the equation of circle S. So that would be x minus 20 squared plus y minus 0 squared equals 178. The point C is 7, 3. 7, 3. And the point D is 7 minus 3. Using your answer from A part 1 or otherwise verify that 7, 3 lies on the circle S, the one on the right. 7 minus 20 squared plus 3 minus 0 squared equals 7 minus 20 squared plus 9 is 178. Job done. By using that, find the area of the triangle DBC. DBC. Okay. The circle on the right has the equation x squared minus 40x plus 400 plus y squared minus 0y plus 0 equals 178. And then the circle on the left, which is at 0, 0, has the equation x squared plus 0x plus 0 plus y squared plus 0y plus 0 equals 58. If you subtract these, you get the line in the middle. They cancel. That's minus 40x. That's 400 plus 400. They cancel. Nothing there, nothing there. That is 120. 120 minus 400 divided by minus 40. So that's the equation x equals 7. So this here is at 7. So 7 to 20 is 13 units. And this height here is 3 units. Isn't it? So it's just a half 3 times 13. So the area is 19.5. A half times 3 times, what did I say? 13. I guess. Maybe. Who knows? Find the size of the acute angle CBD. CBD. Oh, well, if that's 3 and that's 13, it's just tan inverse 3 over 13. To the nearest degree, 13 degrees. The area of the sector ADC is that the area of the triangle ADC is 21. Use this, work out the area of the shaded region that's inside both. Well, it's the sector minus the left triangle. That would give you this sliver on the right, and then it's the sector minus the left. Okay, so it's going to be the sector 23.4837 minus 21. So that's the whole sector minus 21 plus the previous sector, which is going to be 13 over, or the right sector, I mean 13 over 360 times pi or squared minus oh, I forgot to multiply that by 2. So it's actually 39. Because I just got the top one, didn't I? DBC. Yeah, 39. So minus 39 then. Okay, let's see. Hang on. 23.4837 minus 21. So this piece on the left is 2.4837 plus, oh, no, 13 divided by 360 times pi. Oh, my 39 is too big, I think. Oh, but the angle is wrong. The angle is CBD. Again, I forgot to multiply that angle by 2. Silly Stephen. It's 26. Tut, tut, tut. So that's 26. 26 divided by 360. Should have been more careful. So then this one here is 1.3869. Two decimal places, 3.87. Okay, hopefully, man, I didn't screw that up more. Angle CBD, CBD, yeah, I forgot to multiply that by 2 because I was just doing 3 over 13. And then the area has been multiplied by 2 as well. Okay, well, that's fixed now, hopefully.